Hello everybody, I'm Alexy Khrabrov, the organizer of SF Scala, and here we are on location at Lithium, where we have an amazing meetup tonight. And we have two talks. One is Fast Parse with Harvey Lee, and the other one is about Akka streams with Paul Kinsky. And here with us we have Paul Kinsky. He's also my colleague at Nitro, so we share a lot of common interests in Scala and reactive processing. So I'm gonna ask Paul a few questions. So first of all, how did you get interested in Scala, and maybe you can outline a little bit your career path and kind of your technical track, and like how did you arrive at this set of technologies?
All right, starting at the beginning, I guess. Originally went to school for electrical engineering, realized I only really liked digital circuits, didn't like all the radio frequency engineering, calculus stuff. It was all about discrete math. Then went into industry, started working initially at this big company, Pegasystems, working in Java, and started working on some side projects, playing around with Python because enterprise Java isn't that easy to get started with or easy to do interesting things with. Eventually, I noticed that it's harder to refactor stuff in Python, harder to work without the power of a type system, even though, say, something like Java, you're sort of restricted by the verbosity of the type system. So I figured, started looking into Scala. There's this Scala Coursera course. I think everyone watching this has probably heard of it. That's taught by Martin Odersky. Took that, sort of fell in love with the language. Yeah.
That's amazing, right? Like every time, we can learn new things. I didn't know you did a lot of Python before. So we have actually have a lot of data scientists who predominantly use Python, and they think it's hard to switch to Scala. Maybe you can kind of explain to some of these folks, hopefully watching us in the future, why kind of Scala makes sense for software engineering, for data processing, and is it really dramatically harder than Python, or kind of what's kind of a good way to approach Scala if you are a Python developer?
Yeah, well, all right. So one of our engineers, Marek, he gives this talk on functional programming and using Scala for data science. Really great. But one of the examples from that really just comes to mind is using Python, running this 12-hour job, doing a lot of just training some model or something, and then at the very end having just some formatting error in a string or some type error that wasn't caught until runtime, just torpedo the whole job, causing him to have to run it again. So one thing I'd say is Scala, just because the types are checked at compile time, you can avoid that happening. I don't know. I mean, generally, there's a great community of people working in Scala. There are a lot of people who are data scientists who work with complex math, complex models as their main job, who create libraries in Scala. There's a lot that's already there. It's not like it might have been 5 years ago or something. You don't need to build all your tools from scratch.
Cool. So speaking about community, right? So I think we first met at Northeast Scala Conference, which is a fantastic example of Scala community. Maybe for folks who didn't yet go to Scala events, maybe you can summarize a little bit what kind of Scala community is for you, how it helped you to work with Scala, and what's special about it.
Yeah, so we met at Any Scala, which I think it's a great example of the Scala community because first day, right, it's a standard conference. You just do talks that are pre-scheduled. There's sort of a call for a proposal that goes out beforehand, et cetera. But the second day, it's really cool, really sort of highlights the community. What they do is they just have everyone come in and among themselves organize a day of talks. Just in the morning, everyone writes in a whiteboard what they want to present, and people hash out when and where they'll present it during that day. It's called an unconference. And every time I've gone to Any Scala, twice, there are always really good series of talks that people are trying out before different conferences, or that people just have sort of come up with, that they're just able to just that they just sort of have on the back burner that they can just show off at the unconference.
And you actually did a very interesting session together with a speaker about Akka streams and reactive streams, right? So I just wonder, maybe you can share with us, how did you find this technology, and what's interesting about Akka streams? And for folks who don't know, maybe you can summarize what Akka is, what streams are, and how they connect together.
Okay, right. Starting from the beginning, Akka. So actor model, you have actors, they send each other messages, they each have a queue, they process messages. It's a really great system, sort of great for working with concurrency. You don't need to deal with mutexes, locks, all that like multi-threaded stuff that makes concurrency so hard to work with. You just get this like nice low-level model that lets you describe like message passing concurrent systems. So that's great. I was actually at the time working at a company that had all of our backend systems built in Akka. So you sort of start to notice that you can't really compose actors. You lose a lot of type safety if you're working at that level just with actors. But they're really great for systems where you can sort of like draw out like a finite state machine of all the different states beforehand. They're just like the best thing to do if you have like this specification in your head that you want to just build. So Akka streams, it builds on top of Akka actors, right? So what it does is you use this DSL to describe your stream processing systems. You create these sort of blueprints at a compile time. And these are just like immutable vals. They describe stuff. They're not like actually running stream processing systems. And you use a actor system to materialize them, right? So you turn these blueprints into running stream processing systems that use Akka actors to pass messages. So you get all the benefits of Akka, like the speed, the concurrency, et cetera. And you still have type safety, because all these blueprints you're building and composing are fully type safe. Like every facet of them is described by their types, like including something that like their materialization types, right? Like so when you run, let's say you open a stream that's like connected to a socket, you might get like on the side some value that lets you close the socket, say, and like that's described in the type system. And you get these like really well described black boxes that you can just sort of like plug together like Legos and build up a system from.
So the fact that it's in Scala is actually very valuable because you kind of connect them through types, right? Like you can connect. Okay, cool. That's really great. So, and I know that you're writing a book on reactive streams.
Yes, I am on Akka streams specifically.
Right, on Akka streams for mining, so we know hopefully that will kind of cause more folks to learn about this, and you want to share this knowledge. I wonder, why do you think people should be programming in this paradigm, right? Like I think one of the reasons to write a book is kind of to share your approach and teach more people, right? So how do you think this is gonna improve software engineering practices? How is gonna improve developers' lives and kind of reliability of systems? Why this is an important approach, we should learn about and try?
Right. Well, I think streams are just a great mental model for describing a large class of computation, right? Let's take a few. Like big data, you're dealing with more data than you can fit in memory. You sort of necessarily have to process it chunk by chunk, so you have a stream of chunks that you're processing. Stream processing, right? You have like a stream of log data, you have a stream of events from like Internet of Things devices. For all of that, like the most natural way to process it is as a stream of events or a stream of data. Then you have, for example, like low-level stuff on Linux, right? So you're, say, cat a file, you grep it, you maybe pipe it to another process. That's a source of like bytes being piped through a transformation pipeline and finally to standard out to your console, right? That's a stream. You're looking at like TCP, that's a stream of bytes in order. You're looking at like WebSockets, streams going both ways. Modern services, right? Billion-dollar companies like Twitter, I think it's a billion-dollar company. Anyway, companies like Twitter, we'll cut that bit. They're just like streams of messages being fed from multiple sources, aggregated, fed back to people. Netflix, stuff like that. It's all streaming media. So there's like sort of a common denominator, right? Everyone's working with streams. And if you have something that can like natively in the language of like streams and transformations over streams, if you can define your system like that, then you can do it very concisely, and you can do it in a way that accurately models the problem domain.
This sounds awesome. So we are looking forward to your talk, and thank you very much for sharing with us. Thanks, Paul.
I'm glad to be here.
Thanks.